Welcome to Maths with Jade. In this video tutorial, we will be learning how to find the volume of a prism. First, we need to answer two questions. What is volume? And what is a prism? Volume is the space that a substance or 3D shape occupies or contains. So if I'm talking about the volume of this box, I'm really saying the space inside the box. And if I'm talking about the volume of one of these bottles of water, I'm really saying the amount of water in the bottle. A prism is a 3D shape that has a cross-section that stays the same throughout. A cross-section is a flat slice of the shape. Now, if you look at this, the back and the front is the same shape, and any slice in the middle is also the same, which means this is definitely a prism. Cross-sections are parallel to each other and perpendicular to the base or length depending on if it's standing up or laying down. And perpendicular means at a right angle too. There are some things you need to know before we start. You need to know that the area of a rectangle is the base times the height. And you need to know that the height of a triangle is perpendicular to the base. There's that word again. And the area of a triangle is base times height divided by 2. You need to know that the area of a circle is pi times the radius squared. And you also need to know Pythagoras' theorem. This is because if we are given a slanted length and the base, we need to be able to find the height. Now, if you haven't learned Pythagoras' theorem, please look at my link in the description and that will take you to my Pythagoras' theorem tutorial. So to find the volume of a prism, first, we need to identify the cross-section that stays the same throughout the shape. And then we find the area of that cross-section. But the question is, what do we multiply it by? How much of that cross-section do we have? Well, let's imagine that the cross-section, considering that it's a 3D shape, has a thickness of 1 unit. Well, how many of those can we fit? A whole length worth, which means the volume of a prism is the area of the cross-section times the length. We can do the same thing for a triangular prism. Find the area of the cross-section and times it by the length. And we can do the same for a cylinder. Find the area of the cross-section and times it by that length. And this will work for all prisms. It doesn't matter how complicated the cross-section is. So we should be able to find the volume of this cuboid. Now, because the cuboid is a prism, I know that the volume is the area of the cross-section times the length. So let's identify a cross-section, and I'm just going to use that front side because that stays the same all the way through. Now, the area of that is going to be base times height, 3 times 5, which is 15 centimeters squared. That's my cross-section, and now I times it by my length, which is 4. 15 times 4 is 60, and my units is in centimeters, so centimeters cubed for volume because it is 3-dimensional. Let's take a look at a triangular prism. So we know the volume of this is going to be the area of the cross-section times by the length. So first we need to identify the cross-section, and it's an isosceles triangle. We know the area of a triangle is base times height divided by 2. And that 24 is our base, but unfortunately that 13 is not the height. Let's draw the height on there. And if we take half of that cross-section now, I'm going to draw it over here, we have a right angle triangle, hypotenuse 13, height we don't know, and the base is half of the base of our cross-section. Well, how do we find an unknown in a right angle triangle? Pythagoras' theorem. So substitute in your values, minus 12 squared from both sides, and then square root, and you find that h is 5. So I went through that quite quickly because you should be familiar with Pythagoras' theorem now, and if you're not, really I recommend going and watching my Pythagoras' theorem video. So now we can do base times height divided by 2, which will give us 24 times 5 divided by 2. That will equal 60 meters squared. And now we need to take that cross-section 60 and times it by the length 50. And we get 3,000 meters cubed. One final quick example, a cylinder. So we know it's a prism, so the volume is going to be the area of the cross-section times the length. And we need to identify the cross-section, first of all, and it's a circle, so we know the area is pi times the radius squared. Our radius is 3, so we're going to have pi times 3 squared, and then times the length, which is 20. Now that 3 squared we know to be 9, so pi times 9 times 20, and then 9 times 20 is 180, so we have 180 pi. And if we don't want our answer in terms of pi, then we can write it to 3 significant figures, which is 565, don't forget your units, centimetres cubed. Here's some questions for you to do. They're a real mix of questions, so make sure you read the question carefully. And just a little reminder, for an area of a triangle, you need the perpendicular height. And if these are too easy for you, do stay tuned till the end of this video because I have 3 bonus questions also. Pause the video now. Here are your solutions. Question number 1 is a simple case of the cross-section times by the length. Question number 2, you're best to convert your units to centimetres first. And don't forget to half the diameter of that circle. And then once you've found the volume of 1 coin, times it by 3. Question number 3, find the volume of the pool and then just times by 1000. For the triangular prism, find the area of the cross-section, base times height divided by 2, and then times it by 10. For question 5, you need to split the cross-section into 2 rectangles and then find any missing lengths. And then you can find the area of both rectangles, plus them together and times by 25. So for the 10th question, you know it's an equilateral triangle with side lengths 2. So let's split it in half. We know the hypotenuse of that right angle triangle is 2 meters and the base is 1 because it was 2, we split it in half. Now we can use Pythagoras' theorem to find the height, which I put in orange. Now it's a simple case of base times height divided by 2 and then times by the length, which is 2.5. Now it's time for some bonus questions. Do think really carefully about these and just try your best. Pause the video now. Okay, so for question 1, we just need to take the volume of the cube and minus the volume of the cylinder. So 8 times 6 times 3 minus pi times the radius squared times 6. I hope you remember to halve your diameter for the cylinder inside. And then you just need to calculate what that gives you. So question 2, it helps if we draw out the cross-section. We have a semicircle and a square. We know the sides of the square is 16 and the radius of the semicircle must be half of that, so 8. So now we just find the area of that semicircle, pi r squared divided by 2, and the area of the square. Add them together. And then we want to do that cross-section area times by the length. So the final question of the tutorial. That tank is a cylinder type shape, so label 1.5 meters as the height and the radius we don't know, we need to find. So we know how many liters are in the tank, so we can use a conversion to find the volume in meters cubed of that tank. And we know that the volume is equal to pi times the radius squared times the length. Now I just need to rearrange that to make r the subject. So first I'm going to divide both sides by pi times 1.5. And that leaves me with r squared, but I don't want r squared, I want r, so I'm going to square root. And I get 0.6 meters. Thanks for watching, this has been Maths with Jade. If you enjoyed this video and found it useful, please hit the like button. And so you don't miss out on future content, make sure to subscribe. Feel free to share this video and comment below.